Let's go inside the one device you probably use more than any other. We're going to pull back the curtain on the absolutely incredible, almost magical technology that makes your smartphone's brain tick.
I mean, really think about that for a second. You tap a single button, and in less time than it takes to blink, your phone captures light, crunches millions of data points, and then just presents you with this beautiful, perfect picture. How on earth is that even possible?
Well, the secret isn't just one super powerful brain. No, it's more like a whole bustling city of specialists, all living and working together on a tiny piece of silicon. And that's the key idea we're going to explore.
So let's start by meeting the mayor of this tiny city, the absolute command center for your entire phone.
It's called the System on a Chip, or SoC for short. And the thing that's just wild is the scale. We are talking about 5 to 10 billion tiny little switches, called transistors, all crammed into a space that's smaller than a penny. It's just unbelievably complex.
Right, but like I was saying, this brain isn't just one big blob of raw power. It's a highly organized team, where every single member has a very specific and very crucial job to do.
First up, you've got the CPU, the Central Processing Unit. Think of this as the general manager of the entire company. It's running your apps, it's managing the operating system. Basically, it's telling everybody else what they need to be doing.
Then you have the GPU, the Graphics Processing Unit. This is the artist on the team. Every icon you tap, every slick animation, every amazing-looking game you play, that is all painted onto your screen by the GPU.
And here we go. This is the star of our show today, the Image Signal Processor, or ISP. This is the team's dedicated expert photo editor. Its one and only job is to take that raw, kind of messy data straight from the camera and transform it into the gorgeous picture you actually see.
And of course, we've got the modem. This is the communicator, the link to the outside world. When you hit send on that photo to share with a friend, it's the modem that packages it up and fires it out over 5G or your Wi-Fi.
Okay, so now that we've met the key players on the team, let's actually follow the journey of a single photo as it travels through this tiny city. It's pretty amazing to see how they all work together.
So, it all happens in 4 main stages. First, light becomes data. Then, that data gets moved into memory. Our specialist, the ISP, gets to work processing it, and then another specialist comes in to compress it and save it. Sounds simple enough, right? But there's a massive challenge hiding in plain sight here.
And here it is, the problem. A single, raw, unedited photo from a 12-megapixel camera can be a whopping 24 megabytes. Now, that might not sound like much, but in the world of processors, that is a gigantic chunk of data to deal with all at once.
And this is where things get really tricky. See, the SoC has its own super fast private memory right there on the chip. It's called a cache, but it can only hold about 4 to 8 megabytes. Our 24 megabyte photo is, well, it's way too big to fit. So how in the world does the phone even start working on it?
The solution is this brilliant internal system that's basically a digital superhighway. It's got on-ramps and traffic control, and it's constantly shuffling little pieces of that huge photo from the phone's main memory over to the ISP. So the ISP works on one little tile of the picture, sends it back, grabs the next one, and it does this over and over at lightning speed.
So all of this incredible efficiency, it doesn't just happen by accident. It's all the result of some really clever design principles that are focused on one main thing, getting the absolute most performance while using the least amount of battery power.
So why even bother with all these specialists? Why not just have the main CPU do everything? Well, it's a concept called hardware acceleration. The ISP, because it's built for one job, can process that image thousands of times faster and more efficiently than the general-purpose CPU ever could. It's like, hiring a professional photographer instead of asking your accountant to do the wedding pictures.
And this whole smarter, not harder idea goes even deeper, right inside the CPU itself. Most phones use a design called big.little. They have a few big, super powerful cores for the heavy lifting, like playing a game. But they also have several small, really efficient cores for simple stuff, like checking your email in the background. Your phone is constantly and intelligently choosing the right tool for the job just to save every last drop of battery.
So we get the design, right? It's incredibly clever, but that's really only half the story. To truly appreciate this technology, we need to zoom way in and try to grasp the mind-boggling physical scale we're dealing with.
10 billion transistors. Just let that number sink in for a minute. Not million, billion. That's how many of those little on-off switches make up a modern phone chip. It's a number so huge it's almost impossible to even picture.
Right? I mean, how can you visualize something that complex and that microscopic at the same time?
Well, here you go. And this is the part that just gets me every time. That entire city, with billions of components and all the streets and wires connecting them, the whole thing could fit inside a single grain of table salt. It is genuinely, absolutely mind-blowing.
And as you can imagine, creating these tiny cities is one of the most complex manufacturing processes on the entire planet. It all happens in these ultra-clean factories called fabs. It involves over 100 insanely precise steps, and it's a process totally dominated by just a handful of companies in the world, like TSMC in Taiwan.
So we've gone from a simple photo all the way down to a city of specialists smaller than a grain of salt. It just makes you wonder, with this much power in such a tiny, tiny package, what truly impossible things will it allow us to do tomorrow?